Section 5.2, Day 1, Verifying Trigonometric Identities. We're going to spend a couple of days trying to verify trig identities or to prove that two things are equivalent. Let's just start with two functions f and g are said to be identical if f of x is equal to g of x for every value of x for which both functions are defined. Such an equation is called an identity. So we have an identity, and we also have an equation that is not an identity. It's called a conditional equation. So I have given you some examples of identities. If you take x minus 3 squared and you distribute it out, you get x squared minus 6x plus 9. Those two things are equivalent. Same thing with cosecant is equal to 1 over sine of x. That's an identity. You can prove that one side of the equation is equal to the other side. A conditional equation is 3x minus 1 is equal to 8, where you can actually solve for a value of x. So on both of these, on the conditional equation, there are going to be solutions. But for an identity, if you actually did solve this, what would you get? Well, for the first example, basically everything would cancel out, and you would get 0 is equal to 0. So if we were solving that, we would say there was all real numbers. But that's what an identity is that two things are equivalent to each other. We're not solving these equations. That's what a conditional equation is. We are proving or establishing or verifying that these two things are equivalent to each other. And we will be doing this using our identities that we've learned in terms of the quotient, the reciprocal, the even and odd properties, Pythagorean identities. We'll be using all those different identities to help us prove additional identities as well. So the first one we're going to look at is cosecant of theta times tangent of theta is equal to secant of theta. So typically we start with the more complicated side, which in this case I would say would be the left side. You got two things that are being multiplied. And we're going to use our identities to start to simplify this. So how can we rewrite cosecant of theta? Make sure you have your identity sheet out so that you can look through if you don't remember what these are just yet. So cosecant of theta can be rewritten as 1 over sine of theta. That's the reciprocal identity. Times tangent of theta could be 1 over cotangent, which would be the reciprocal, but we're trying to get to secant. So let's change tangent using the quotient property to sine of theta over cosine of theta. And we're trying to establish that this is going to equal secant of theta. So you can see that the sine of thetas are now going to cancel, and you're left with 1 over cosine of theta. And now we know that 1 over cosine of theta, using the reciprocal identities, is equivalent to secant of theta. So we have established or verified that this identity is true, that cosecant of theta times tangent of theta will always equal secant of theta. So as we start verifying and establishing these identities, a couple helpful hints as you go through and start these types of problems. The first thing is we try to start with a more complicated side. That's not always easy to pick out, but in a lot of problems you'll definitely be able to tell which one's more complicated. Always keep your goal in mind, and what I mean by that is, as you work with one side, keep in mind forms of the other side. What is it you're trying to accomplish? Number 3, manipulate only one side. This is huge. You cannot start to simplify or manipulate both sides of the identity. Do not treat the identity as an equation. You can't add something to one side and add it to the other side. Okay? You are proving or establishing that one side is equivalent to the other side. So once again, you can only manipulate one side. That is put a star by that one. It's a big concept that we struggle with sometimes as we try to do to both sides, but just one side. Sometimes rewrite one side in terms of sine and cosine will help, so pay attention once again to what you're trying to accomplish. Rewrite sums and differences of quotients as a single quotient, so basically combine your like terms, or not combine your like terms, combine your fractions with a common denominator. Try to factor an expression, that's helpful sometimes. And then number 6, write one step at a time. Do not skip any steps during this process. Okay, I don't want to assume anything. I want to make sure that you are correctly going from one step to another. So once again, make sure you are showing all your steps. Do not skip any. So the next process is just looking at a couple of these problems and seeing if we can establish the identity. Example 2, 1 plus tangent squared of negative theta is equal to secant squared of theta. So we got some tangent squared and secant squared. So the first thing that kind of I think of is, okay, something to do with Pythagorean identity possibly. But let's take a look. We have 1 plus tangent squared of theta. So what does that actually mean? 1 plus tangent of negative theta squared. Remember, we put tangent squared, but it's actually the whole thing that is being squared. So what's tangent of negative theta? Well, you can use your even and odd properties. This would be an odd property to move the negative out front. So negative tangent of theta squared. And we're trying to get this to equal secant of theta. So 1 plus negative tangent of theta times negative tangent of theta is positive tangent squared of theta. And if you go back and look at your Pythagorean identities, 1 plus tangent squared is equivalent to secant squared of theta. So secant squared of theta is equivalent to secant squared of theta. Once again, I only manipulated one side, dealt with the more complicated side, and made it, all the way down to secant squared of theta is equal to secant squared of theta. Never stop one step short just saying, well, 1 plus tangent squared is equal to secant squared. No, you have to go all the way down to the end where, the left side and the right side are equivalent. And you'll also notice, once again, I showed every single step along the way. I didn't skip any steps. On example 3, I would pause the video at this point and see if you can kind of go through and manipulate the left side. It's definitely more complicated. The right side is equal to 1. See if you can manipulate the left side. Use your identities to see if you can get it to equal to 1. So go ahead and pause and see if you can do that yourself. Alright, here we go. So sine squared of theta. We could change that to 1 minus cosine squared, but once again, we're trying to equal it to 1. So let's look at the 1 plus cotangent squared of theta. Once again, those squared sometimes make me think about Pythagorean identity. So once again, 1 plus cotangent squared of theta is equivalent to cosecant squared of theta. And then now, if we look, sine squared and cosecant squared, those are reciprocals of each other. So sine squared of theta times cosecant squared is 1 over sine squared of theta. The sine squareds cancel out, so therefore 1 is equivalent to 1. So once again, we've established or proved that sine squared of theta times 1 plus cotangent squared of theta will always equal 1. Alright, and the last example we're going to look at in this video is verifying the identity cosine of theta times the quantity tangent of theta plus cotangent of theta is equal to cosecant of theta. So once again, I think we can all agree that the left side has more stuff. It's a little bit more complicated than the right side. So we're going to try to get the left side equal to cosecant of theta. So as you look at this, and once again, if you want to pause the video and try to do this one yourself, definitely do so. But as you look at this one, what is it that we can do? I don't see any squareds, so I'm not thinking about Pythagorean identity. We can use our reciprocal, we can use our quotient properties. Tangent and cotangent can both be changed to sine and cosine. So once again, just trying to think about the different ways that we can do this. So maybe let's start with the inside of the parentheses and rewriting tangent and cotangent in terms of sine and cosine. Remember, we're trying to get to cosecant. So keeping other forms in mind, we're not going to change this to 1 over sine of theta, but remember, if we can get the left-hand side to look like that, then we have made it to the establishing part. We would know that that would work. So I'm not going to change that side, I'm just thinking about it in terms of what it actually represents. So tangent, I want to change to, because if I need 1 over sine, then tangent we can change to sine of theta over cosine of theta. And then cotangent will go the other way. It'll be cosine of theta over sine of theta. So this is the quotient property. So what does that do? Well, I'm not sure just yet, but let's kind of keep working through this. We could combine our two fractions, we have to find the common denominator. Before we do that, maybe one thing that we can do is just go ahead now and distribute the cosine. So if we distribute the cosine, you'll notice that the cosines of thetas will cancel in the first fraction, and that'll just leave you with sine of theta. I'll put over 1, plus, nothing cancels on the other one. We actually get cosine squared of theta divided by sine of theta. Now remember, cosecant of theta is 1 over sine of theta, so you'll notice that we have the sine of theta in the denominator, which is what we would like. So now we can find a common denominator. So we're going to multiply the first fraction to get that common denominator by sine of theta over sine of theta, which is just a form of 1, so we're not changing anything here. That'll give us sine squared of theta over sine of theta, plus cosine squared of theta over sine of theta. And then now we have a common denominator, so we'll rewrite this as one fraction, sine squared of theta plus cosine squared of theta over sine of theta. Alright, and now we do have sine squared plus cosine squared. That is our Pythagorean identity, our main one. So that leaves us with 1 over sine of theta. And there you go, that's what we were looking for. So now 1 over sine of theta can be rewritten using the reciprocal identity to be cosecant of theta is equal to cosecant of theta. So once again, we have proven or verified the identity that cosine of theta times the quantity tangent of theta plus cotangent of theta is equal to cosecant of theta. So once again, we're just using all the different identities that we have done, from Pythagorean to reciprocal to quotient to even and odd properties, to once again prove or establish these identities. And once again, the last thing is just kind of look back at what you've done and create a summary as to what are those important parts. What are we trying to accomplish in this section?